Hey guys, and welcome back to this Python 101 programming series. So this video is going to be a little bit different in that we're not going to be looking at our Naughts and Crosses example. Instead, I'm going to give you a little bit of a challenge to do. And the challenge is going to be simply to order this list of numbers. Or rather, what I want you to do is create your own list of numbers and create an algorithm to sort that list in ascending order. So get it to go from the lowest number to the highest number. That's the challenge that I want you to do. So how do you think you're going to go through this? Well, if you're not 100% sure already, I would just Google it, have a look, see what you can find, and what you probably find is a number of sorting algorithms. And some of them are a little more complex than the others, some of them are quite easy to implement, some of them are more efficient, but if you come from an A-level maths background or a computer science programming background, then you might already have an idea of these sorting algorithms, which one is best, which one isn't so good, which one's easier to do. So yeah, so what I recommend is you pause the video now, have a look at these algorithms, or just in general see if you can sort it on your own, and yeah, come back in a minute and we'll go through it. So pause the video now and go through it. Assuming that you've paused the video and you've done it and you've come up with a solution, great stuff. If not, no worries, we're going to go through it. And if you didn't pause and you just want to watch the video in general, then hey ho, why not? So, the way I'm going to do it is I'm going to be looking at one of these sorting algorithms. So what I'm going to do is I'm going to look at the bubble sort algorithm. And this is how the bubble sort algorithm kind of works. So you've got a list of numbers. We've got -2, 0, 11, -9 and 45. So what happens is we say, okay, we've got -2 and we've got 0. Now, is -2 greater than 0? If it is, then swap. If it isn't, or if it isn't, then don't swap. And in this case, it isn't, so it doesn't swap. Then it goes on to the next one and it says, is a 0 greater than 11? If it is, swap. If it isn't, don't swap. It isn't greater, so it goes on to the next one. And now we've got 11 and -9. Is 11 greater than -9? Yes, it is, so we swap them. And this is now our partially sorted list of numbers. And there it does again. -2, 0. It isn't, so we don't swap. 0 and -9. 0 is greater than -9, so we swap them. And again, this is now our partially sorted list. And finally, we've got -2 and -9. -2 is greater than -9, so it swaps them. So this is the general sort of algorithm that we're going to be looking at today, and we're going to implement it in Python. So, one caveat that I should have mentioned is there is already a function in Python which sorts a list of numbers, and if you use that, then that's cheating, and I instruct you to go back and delete all your work and do it again, but don't use the sorting algorithm, or don't use the sort function that Python uses. In general though, if you want to have just a general look at the sort in Python, you can do numbers.sort and then print numbers. And as you can see, we have got a sorted list of numbers. However, that's cheating if you did it. So go back and do it yourself. So let's now have a look at the bubble sort algorithm. So, well, what do we need first? Well, we need a way to access the individual element inside our list. So how did we do that before? We used a for loop. So write out a for loop. We're going to say for, let's say for I in range. I'm going to say numbers. Sorry, no, we're going to say the length of the list numbers -1. And we'll get onto -1 in just a second. So we've got that. Now we need, so we've got the individual element. Now we need to say, is that element greater than the element +1, so the element in front of I. So how do we do that? Is it greater or isn't it? We use an if statement. So we say if, we say numbers I if numbers I is greater than numbers I plus 1, then we swap them. So it might be if that you got to here that you would have created a temporary variable. So what you would have is maybe I and I plus 1, I goes into a temporary variable, I plus 1 goes into I, and then that temporary goes back into I plus 1. That's how you swap them. Well, in Python you don't need to do that. You can simply swap in place directly, which I think is quite nice. So we can say numbers numbers I, comma, numbers I plus 1 is equal to numbers I plus 1, comma, numbers, like so. And then if we print out here, we can print numbers out. And we run this. We can see that although it's not completely sorted, it has sorted a few elements. So it's sorted the 5 and the 4, for example. It's sorted the what was it sorted? It's sorted a 5 and an 8. It's sorted 4. It's sorted a few. And as you can see, you know, the 0 which was at the end is now 1 in front. So we're definitely on the way to solving it. But how then do we get it to, you know, we've done it once, how do we do it again and again? I mean, in the previous example, we did this, it came out with a partially sorted list, so we need to go back and do it all again. And we need to go back and do it all again until it's solved. So there's a few ways of doing this. One is a fairly easy but slightly inefficient way of doing it, and the other was slightly better. So we're going to do both. So one way of absolutely making sure that your list will be solved is to simply go through the list using this. So that's just checking each individual one, but then go through it again. So in the previous one where it went through it, and then we kind of did a second batch and a third batch and so forth until we solved it. In this case, we're going to do a naive approach in that we're just going to go through as many times as numbers actually is. We're going to go through the length of numbers. So how do we do this? Well, we create a nested for loop. And we can say for, let's say, x in range, the length of numbers times 1. And if we now print that, we can see that we do indeed have our sorted list of numbers, which is excellent, which is awesome. I said I was going to say why we need the -1. Well, if we get rid of it, run it, we get an index out of range exception. And the reason for this is that we're doing I plus 1, so as soon as I gets to the final digit, we're doing I plus 1, so we're going to the next digit, but there isn't another digit. That's at the end of our list. So we just need the -1 in there, so we don't get that error. And yeah, that's fine now. Oh, additionally, so as you can see, we'd never use x. X is a variable we've defined, but we don't actually use it. That's because we don't need to. We're using a range-based for loop, which is fine, but we don't care about like the actual index or the value. So what we can do instead is just using the underscore, and that basically tells Python we don't care about indexing anything in this case. We just want you to go through it a few times, or as many times as we say. And we run it again, and we get out the same value, which is great. But as I said, this is a naive and inefficient way of doing it, because it's going through, like it's essentially going through, how many times is it going through? It's going through 3, 6, 9. It's going through at least 10 times, which is ridiculously inefficient. Because what happens if you've got, in fact, I'll do it. Why not? Let's say we've got. That would be an easy way of doing it. And I'll also print there as well. So let's run this, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, which is and then we'll need. So, realistically, it might be best if we put it there. Zero, 1, 2, 3, 4, 5, 5, 5, 7, 8, 9. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, it goes to 9. But what happens, say, if you do Control C and change it, so, and let's say that 9 and 8 are out of order. Run it again. We get the exact same number. We can see that, you know, these have been changed on the first go through it. Really, I should just put them there as well. One, two, three. No, that's more than I was expecting. Oh, yeah, of course it will. Sorry, I'm being thick. So let's do that, and let's do that. Okay, so that's the original list that we've got, and as we can see, the first pass through it, it sorts it, but then it continuously goes through all of the, it continuously goes through the loop again, irrespective of the fact that it's already been solved, it's already been swapped. So the best way we can do, or the way we can do this, is we can say, well, I guess in bubble sort, or in any sorting algorithm, you know when a list of numbers is solved because you don't swap anymore. Okay, so why can't we say while the swap is true, say, you know, then you can continue going through, and then you reach a certain point where you don't swap anymore. So you can say swap is equal to false, and when that starts, you know, you break out the loop. So let's try that. Let's change this for loop to while loop. So we can say, first of all, sorry, we'll need a swap boolean. So swap is equal to true, and we can say while swap is true. We can do that. And then, yeah, so if we run this now, it's just going to loop forever because we're not saying that it's stopped. We're not saying swap is equal to false. So let's have a think about this. When in this loop are we actually swapping? I think we're swapping here because we say if the number is greater than the number plus 1, then we swap. So we can say swap is equal to true. So if you say that swap is equal to true there, why can't we just say right up here swap is equal to false? Let's try that. Let's see what happens. We run it, and as you can see, well, we get the same value. We get the it does sort our list. As we can see there, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is great. But if we now move this print statement, and let's say we put it there, and it might just be that we need that many swaps. Let's change it to 1, 2, 3, 4, 5, 6, 7, 9, 8, and we run that. Now we can see that it only goes through 2 times. So in the previous example, we had it going through 9 times, I believe. In this instance, because we're using a while loop, we're saying while while we keep swapping, keep going. If we don't swap, stop, we break out of it. And this, therefore, is the result. That is what we had, and this is our sorted list of numbers. So I hope that was interesting, or I hope that that helped out a little bit. There's obviously plenty of ways of doing this and implementing many different sorting algorithms. There's probably one additional optimization you can do with this, which I encourage you to have a look at. I guess one thing you could say is that every single pass through, you're always going to have these two numbers in the right order, because that's how it works. You swap, and then you swap, and then you swap, and then you swap. So at least this number will be in the right order. So then I guess you can go backwards each time. So when you do it through one pass, so let's say let's go with a previous one. So in this one, for example, if we go through the first pass, 9 is at the end. So 9 is our biggest number, but also the first pass through, it's at the end. First pass through, we've got our biggest number. And as you can see, every single pass through, we kind of have the next biggest number, the next biggest number, the next biggest number. So instead what you can do is you can say, okay, that's fine. So we know that this number is the greatest number. We know that's definitely sorted. And then in this instance, we know that those two numbers are definitely sorted. We know that these three numbers are definitely sorted. So what we can say is, instead of looping through the entire array again, we can almost say the number of iterations through. So if we've gone through 1 or 2 times, then we can almost do minus, or length numbers minus 2, minus 3, minus 4, minus 5, or something like that, because then that will get you down to probably 2 or 3 digits, and those two will be the final ones that you swap. And that might be a better way of doing it, because, you know, for example, we're down here, most of these numbers are in the right place, so we're kind of just going through them irrespective of what, you know, they've already been swapped. So what we can say is, you know, if we've already been through 5 times, then we know that the last 5 numbers are swapped. They're in the right place, so we don't need to worry about them. We can cut our list in half, or we can just say go up to numbers I minus 5, let's say, and you will only do a subsection of that list. So that's an optimization you can have a look at. So yeah, in the meantime, I hope that was okay, hope that was interesting, and yeah, see if you know, have a look at a few other sorting algorithms and see if you can implement them. In the meantime, have fun with those and stay safe. Cheers.